A webinar on machine learning, deep learning, hands-on experiments. RDBS Geeta Deep Enterprises. In association with Sharad Institute of Technology, College of Engineering, Ichokaranji. Sponsored by Institution of Electronics and Telecommunication Engineers.
Welcome to MLDL webinar Day 8 session. Well, till now we have learned how to configure convolutional neural network, recurrent neural network using LSTM and GRU. Well, today we are going to see the pre-processing required in image processing applications. It may happen that while extracting features using convolutional neural networks such as VGG16 or similar, it may happen that some of the features are not properly available at the output. Hence, sometimes pre-processing such images before giving input to the convolutional neural network may be the mandatory tasks. So, as a matter of contents in our webinar, we are going to touch the topic of pre-processing of the images, into which we are going to see how to change the intensities in terms of contrast information associated with the particular image, edge detection, local binary pattern and HOG features extraction, and how to check the outputs while using these packages from SKImage. Well, we had also mentioned OpenCV or similar tools in the contents of the webinar, but writing a particular code using Python in OpenCV package may not be the mandatory task required while performing the pre-processing. If similar types of methods are readily available from some other package, we can simply import them and apply on the images. So let's see the experimentation for pre-processing of images.
So first of all, we have to install SKImage package. So directly SKImage command is not available, so you have to install scikit-image. So for that, pip3 install scikit-image. As I have already downloaded this, it will indicate the requirement is already satisfied. Next to that, let us write a program from SKImage dot filters import threshold en, from SKImage dot exposure import rescale intensity, sometimes intensity variations are required in the image for auto contrast or similar type of processes. Next to that, for input output handling of images, we will import imread and imsave. Next to that, img is equal to imread 001.png. So these commands you may find similar to MATLAB. So there will be little less difficulty while understanding the concepts behind the syntax and reading type of the data. So here we find the threshold value first using threshold en command. Next to that, we want to convert our image into little bright. So we will rescale its intensity. So we will give img as input and its threshold value 0 to threshold. So this threshold is en threshold basically. We have obtained in previous line command. Next to that, the application should be within 0 to 255 stages only. And next we will save this image as out.png. JPG, which is the bright one. Also you can save image as PNG instead of JPG. So let us run the program. I have saved this program using trial1.py. Well, I would like to repeat the command here if you missed this. First of all, install scikit-image, then this is trial1.py. I have saved this with trial1.py. So Python trial1.py. Well, we forgot to put 001.png image in our folder. So let us paste that. Yes, without any error it has run. Yes, we get here two images in the folder. So this is input and this is output. So you can check how the brightness has been changed from original input to output. So sometimes such a kind of a pre-processing is required on the images before going to feature extraction and classification stages. So let us divide the threshold by 2 and check the difference. There is no much difference actually. Let us divide it by 25. So it will become very small threshold. So we are trying to minimize the range of applications. So here warning is been displayed that low contrast values. So the values are not lying within the 0 to threshold. So threshold divided by 25 is very much less. Again 3 is also very much less. Only 2 is working. So let's change it by multiplying to 2, then observe the difference, or 1.5 only. Yes, little difference is coming. So as the range of upper threshold goes on changing while applying intensity variation, next to that skimage.feature we will import local binary pattern. This term had been discussed or called by one of the participants from our group. So instead of writing a separate Python code using OpenCV, simply call up the function here or method from skimage and pass the image to it to get the feature pattern. So we will apply on both the images that to observe the difference occurred while extracting LBP features on both original input and bright images. So let us first save them. So out 1 and out 2, 3 outputs we should be able to see. Well, here is one error that it is missing two required positional arguments P and R. So we have to provide number of points and radius while extracting local binary pattern. So r is equal to 3 we define here. 3 stands for the pixel, so 3 pixel radius we call it as, and total number of points should be 8 into r. So that much size of the structuring element will work on actual LBP processing. Well, by default there are variety of LBP methods, just like clockwise or radially out, up down, top down, bottom up kind of. So by default it is a clockwise. So here we are having some error again. The parameter image must be 2-dimensional array. As we are trying to pass 3-dimensional image, LBP is not going to work. So let us convert first our image into 2D, that is to grayscale. So we will make use of RGB to gray command. IMG. So this way IMG will get converted into 2D. Next to that, we have to import RGB to gray command. It lies in color package of SK image. So this way we import and then use. So both images we have to convert into 2D, bright and IMG. So then only instead of saving each time, let us call matplotlib pyplot as plt to show the results during the run in figure window. So it will become easier to observe the processings for every stage whenever we want. So here we call plt.imshow for IMG and before RGB to gray, after RGB to gray, for both intensity corrected and original input images. Next to that we will put feet and feet 1. So what LBP pattern we are getting, that also we can observe in the figure window. Yes, so this is original input. RG, yes, spelling mistake, RGB should be there. Okay, here correct. Again original input, and this is grayscale image. Now this is appearing like a different color map, not exact grayscale color map. So again, and to make it to appear exact grayscale color map in the figure window, well actually it is a 2D image, but while showing in the figure window it is a processing of matplotlib. So in processing you have to set color map to gray, so which will actually show you the correct grayscale image. Otherwise in one of the color monochrome format it will show like a temperature kind of image, temperature map it will show. Yes, here it is a grayscale, exact grayscale of the input. This is a bright converted and grayscale of a bright image. This is LBP of original input, and this is LBP of bright image. So you can observe that only the required leaf area has been converted into proper feature map. Partial background is masked by simply no binary pattern. Again, as we have saved this, you can observe these things into grayscale format, local binary patterns. So this is for original input and bright image. So now from SK image dot feature, let us import HOG. So we will try to find out HOG features: histogram, orient, gradient. Well, for particular command, most of the time you can refer online documentation of SK image and check the syntaxes based on which what type of input should be given while executing the command in our program. You will be able to understand. So here we have to pass 3 arguments. First of all, the image onto which we have to perform the HOG operation, then orientation, then pixels per cell as 16 by 16 window, and cells per block as 1 by 1. Next to that, we have to enable visualize. So we'll apply on both the images, IMG and bright, and to differentiate previous output, we will change them with the number. So HOG image and HOG image 1, 2 outputs we get. So pl2.show HOG image plt.show. Next to that, we will turn off earlier plt show commands so that directly we will come to the HOG outputs. So hash will convert commands into comments in the Python. Okay, so let's show the result in after coming execution. Result has not been displayed. Okay, so we can also convert HOG image into different intensity change to have better output. So I think that part is remaining here. So you will simply rescale the intensity just like previous command. So output of HOG is HOG image, which we are rescaling it to the range 0, 10. So 0 to 10, all the pixels will get converted. Next to that, run. little mistake. I think color map. Well, it was I am sure requirement actually. There were no other error. Yes, so here we get HOG features of first image, HOG features of second image. As we have not set color map to gray for second output, it is showing some other color. After all, it is a monochrome itself, but the color is not set to gray. So by default, whatever the color is, it will take in. And so first of all, let us observe the output without rescaling the intensity. This is for original image. This is for bright image. So there is little difference, very little difference because of intensity variation. You can also use this command for the sake of changing intensity in the range the way you want. So let us change intensity of both original and bright image after getting HOG. Okay. Well, for eyes we see at the time of figure window, when we see, for our eyes it is maybe little less sensitive, the difference. But actually if you observe by checking the pixel values by printing HOG image before rescaling the intensity and after rescaling, just like a previous experimental scenarios, that to observe the pre-processing we had printed the image so that pixel values are printed in command line. So now let us operate edge detector. Some of the applications may require edge detectors, so we will use Sobel operator from the filters and we will check the output for both type of images. Original and bright. So separately filters we have called, because of which filter.sobel method we can call. So this is Sobel operator on bright image, original image, and this is on bright image. Well, this has shown perfectly the region of interest of deceased area. So we will call Canny edge detector after Sobel. So can edge is equal to Canny of IMG. Next to that, you can also specify the threshold using sigma value in Canny edge detector. Well, little syntax error while importing Canny. So let us put comma and then run the program. So this is Sobel output. This is Canny without sigma. This is Canny with sigma. So you can observe the difference. With respect to the application requirement, you can change the values of sigma to get more details of edges. Next to that, let us import morphology from XK image to perform morphological operations. Well, while using these commands, you will have to refer syntax first, so that what input should be given to particular method for morphological operations, you will be able to understand. Diameter threshold. Okay, it is a diameter closing operation. We have called simply closing, that's why it is showing some error. Well, there is also closing operation available, so as per the requirement you can use. Well, diameter closing is requiring grayscale image as an input. Well, here you can see the error that we had passed Canny edge detected output to the input of morphological operations. So we have to change it to well, it's just simply the confirmation I'm showing you. That both the Canny edge images are binary. Edges are white and remaining area are black. So white is represented by 1 and black by 0. So such a way binary image is formed. So here it needs integer 8-bit image. So it should be within 0 to 255 values, not the binary one. This operation takes little extra time. Yes. So this is diameter closing operation. A little difference in white area that can be seen in this image. So this way closing operation takes place. You can save all the results in the format you want, PNG, JPG, TIFF. All the formats are supported by IMSAVE. Well, this pre-processing and its time consumption should be dependent on application requirement. As far as we are concerned with deep learning experiments, there are large number of images you have to process, which may constitute 5,000 to 50,000 or 1 lakh images. And if all the 1 lakh images are to be pre-processed, then you can consider that how much time it will require to simply pre-process all the image and then training. So as we had included these pre-processing tasks in our contents of the webinar, we just touching this topic. Well, OpenCV we are not using for pre-processing because our intention is not to learn how to use OpenCV, but our intention is to learn how to pre-process the image. So if some of people may expect to write local binary pattern feature extraction procedure for the image using OpenCV only, but it will require 10 to 15 lines of code. But here in SKImage that method is readily available. Other morphological operations that are area closing, area opening, ball operation is to construct structuring element, binary closing. Well, this can be used binary closing on K-nearest detection. So this is a variety of morphological operations available in SKImage. So instead of writing separate code using OpenCV, you can go for this.
So this way, along with such a morphological operations, we can also perform edge detection, HOG feature extraction and LBP feature extractions on the images. We have considered a particular leaf image for the sake of experimentation of today's session. You can also go for some other applications which may constitute image processing associated with lung cancer, brain tumor, kidney tumor, breast cancer or similar kind of a medical image processing applications. Also, you can apply such a processes in image enhancement techniques using deep learning approaches, in which it may be required to pre-process the image. Well, this was sufficient in pre-processing tasks in our webinar. Thank you.